So, hi everyone. Uh, this is Bharat Balaji. I'm going to teach today's topic algorithms and flowcharts in C programming language. As a programming starts with writing the steps, how many steps are there, and, as a programming concept includes the number of steps, instructions. The program is a set of central instructions given to the computer to complete a task. Okay. And before going to instruction, we're going to see some of the techniques that we already come across to come to the programming language, that is algorithm. Okay. So algorithm is a step-by-step procedure for doing a complete task. So it describes each and every task, whether it is minute or whatever it may be, small step or small operation also given to the uh, computer. So that is a very step by step. Each and every step instruction is given to the computer, that is called as algorithm. Okay. And the algorithm development objectives are following of the different development objectives. At the end of this unit, the student will be able to know what is the definition of the term algorithm. Okay, the student will be able to learn what is the definition of algorithm, and he is able to give the 5 properties of a good algorithm. He is able to give the good properties, the 5 good properties of the algorithm, and he is able to make a algorithm. He is able to write an algorithm, create an algorithm for a given problem that is stated by other, create an appropriate algorithm for using the properties which are stated by the customer. Okay. And he is able to use the concept of abstraction and top-down design in creating an algorithm. Okay. By creating an algorithm, there are 2 concepts are there in the characteristics of the algorithm. This one is abstraction and top-down design. How we are going to design the algorithm is given by the top-down design. That means we are going to go from top to bottom. The procedure is started from at the top, and it is going to be end at the end. So abstraction and top-down design will be discussed in this class. He is able to begin to think about the kinds of problems that have a computing solution. He is able to know how to solve the solution, how to solve the solution for different kind of problems. So by using this, we are having a typical programming task can be divided into 2 phases. One is a problem solving phase, and another one is implementation phase. Problem solving phase means produce an ordered sequence of steps that describe a solution of a problem. Before going to give the solution, it has to analyze the problem, what are the alternatives for that particular problem, and what are the attributes we have to take into consideration to solve the problem, and what are the different steps to complete this particular task. And this sequence of steps is called as an algorithm. Okay. Different steps we have to take for the problem solving procedure, and these steps can be called as algorithm. Coming to the implementation phase, the implementing the program in some programming language, whatever it may be programming language, but we have to write the program after completion of the algorithm. So before writing an algorithm, for coming to write a programming language, in any programming language, whether it is a C programming language, C++, Java, Python, or any other programming language. If you want to write a programming language, we have to write the solution which is a possible solution in an algorithm. That is the possible steps what we have to do in the program is written in the algorithm. That is the implementation phase which is written in programming language, and problem solving phase we are going to write the steps which are possible to solve that particular problem, that is known as algorithm. Okay. Coming to the definition of an algorithm, a logical sequence of steps for solving a problem is a common definition for a algorithm. That means a generalized definition. A logical sequence of steps for solving a problem. According to Dale and Lewis, scientists, he given the definition for algorithm, a plan of solution for a problem. A plan of a solution for a problem. And, technically, algorithm is an ambiguous and precise set of steps for solving a problem or in a finite amount of time using a finite amount of data. That means unambiguous means without any confusion, it's a straight away direct solution without any complications or any complex instructions we are going to give. And precise means very short, indirect way of giving a solution. The set of steps must be without confusion, that is unambiguous and precise, that means short and sweet, for solving a problem in finite amount of time. That means the time must be within a bounded time, not much longer than whatever the real time, and finite amount of data. We have finite amount of particular data and particular time. We are going to complete this particular task with the help of an algorithm. That is a definition of an algorithm according to scientists Dale and Lewis. One more definition is given by the Shackelford and Russell in his textbook, that is Introduction to Computing and Algorithm. The definition is an algorithm is a specification of behavioral process. It consists of finite set of instructions that govern behavior step by step. Okay. An algorithm is a specification of a behavioral process. It consists of finite set of instructions that govern behavior step by step. Each and every step by step. One step, first step is completed, then it go for the next step. Then second one is completed, and then again go for the third one. Like this, the step by step procedure has to be given in an algorithm. This definition is given by Russell Shackelford. He is mentioned in his textbook Introduction to the Computing and Algorithm. Come to notice that we need to notice some terms that like finite. Finite means exact. That means what we are going to give a solution within a known and a number of steps. The algorithms should lead to an eventual solution. Okay, the algorithms should lead to an eventual solutions. And the step-by-step process is that each step should do one logical action. Just now said that step-by-step process means if one process, first step is completed, then go for the next step, second statement. The second instruction is executed, then go for the third one. After third, fourth, then the number of steps are just finite, not infinite. They're going to give the solution within a small instructions. Okay, and the step-by-step process in the step-by-step procedure, each step should do one logical action. Each and every step must and should have logical action which is going to give the solution in the way. Okay. Algorithms are addressed to some audience consider like a set of instructions for building a child's bicycle. So here we are going to see some of the real-time examples how we are going to write the algorithms in our generalized in our real life problems. See, we are here we are going to see some of the examples like a instruction set of instructions for building a child's bicycle. How we are going to give the instructions when a child is going to learn a bicycle. So we need to balance the bicycle on two tires by using the help of pedals. How the pedals are to be balanced. How the say bicycle has to be make a movement without any dropping from the bicycle. So we need to maintain the balance and the cycle which is not to drop from the bicycle. Another example is a diagnostic checklist for a failure of some system on the space shuttle. Some system on the space shuttle. We are going to give the what are the different failures of some system, some problems, failures that is encountered in the space shuttle. Okay. Any mechanical device which is we are going to operate will get some of the problems while operating them. So what are the different problems and what are the different failures that we will get in that particular things will be given as a checklist. Those are like given as a some algorithm like only step by step. And the algorithm for what to do when a nuclear reactor begins to overheat. Whenever the nuclear reactor begins to overheat, what we have to do? The steps has to be given in a sequence. We have to do so and so and so and so, so and so, so and so, like in a sequence of steps. We have to give the sequence. The sequence is important. Okay, an algorithm that will run on a computer system to calculate the student's GPA. How to calculate the student's GPA will also given in the algorithm. Okay, in the diploma polytechnic students nowadays we are getting a consolidated memo. Consolidated memo will have the steps to calculate the GPA and calculate the percentage from that particular GPA. Okay. Now we are going to compare with the good and the bad algorithms. Why we are going to call good algorithms and why we are going to call bad algorithms. Okay. All the algorithms will have input as well as perform the process and produce the output. Okay. Whatever the algorithm or problem solving or program, anything which is going to we are going to write, everything will have input and it has to perform some task or some operation, then to produce an output. Okay. And then a good algorithm should be simple and relative. Okay. Good algorithm should be simple and relative to that particular problem. The second most point is complete and account for all the inputs cases. Okay, it should be complete. Without incomplete, when we give incomplete solution, a problem may or may not complete the output. Okay, so for that, the algorithm must be complete on account of for all the inputs as well as different cases which are there executed in the program, and that must be right. That means it should be correct. Okay. It should have appropriate levels of abstraction. That is grouping steps into a single module. levels of abstractions. That is, good algorithm should have appropriate levels of abstraction, grouping steps into a single module. We are going to divide some particular task if the problem solving techniques are having different cases. Each and every case written as a one group. Okay, and if we have some 2 3 cases, the 3 cases are given written as separate group, and after completion of 3 separate groups, those 3 groups are combined into a single module as a whole problem solution, and it is to be mnemonic scrap. Okay, it should be mnemonic and scrap. Coming to the word precision, we are going to give the algorithm definition as it must be precise. What do you mean by precision? Okay, precision means that there is only one way to interpret the instruction. That means we are going to give the unique sentence or unique instruction, which is unambiguous without any confusion. That's a gunshot sentence. And words like maybe, sometimes, and occasionally have no business in a well-developed algorithm. When we are going to say that this algorithm is precise, when we are not going to use the words like maybe, sometimes, occasionally. These three are not giving exact solution. They are giving alternatives. Maybe means either this one or that one. Sometimes, maybe not all the time. Occasionally means not regularly. We cannot give the permanent solution with these terms. That's why we are not going to use these type of terms in an algorithm. The terms must be used in the algorithm are without ambiguity. It must be precise, without any confusion, direct solution, exact solution. And instead of maybe, we can specify that exact circumstances in which an action will be carried out. Instead of maybe, we can specify that exact circumstance in which an action will be carried out. Coming to the simplicity, these are the different characteristics of algorithm, for the precise and the simplicity, okay, and having the abstraction. Okay, simplicity means the problem must be simple to understand everyone. A common man has to be understand so that he can solve that particular problem. Okay, the simplicity means simple can be defined as having no unnecessary steps and no unnecessary complexity. Okay, simple can be defined as having no unnecessary steps and unnecessary complexity. That means you may lose the points if your algorithm contains unnecessary steps. So whenever we are going to use unnecessary complexity or unnecessary steps, the good points will be lost. That means your algorithm will going to be a bad algorithm, not a good algorithm. If you use unnecessary things, that is steps as well as complexity. Each step of a well-developed algorithm should carry out one logical step of the process. Okay, one logical step of the process. And it should avoid something like take second right after you exit at King Street. So we are going to take a one real-time example. We have to avoid something like take second right after you exit at King Street. So that means you are going to out from the King Street, then take that second right after exit, like this. This is reality examples which I'm going to give you. And it has the levels of abstraction. It has, the algorithm has levels of abstraction. So from the Oxford English Dictionary, the abstraction is defined as, first we have to know what is an abstraction, then we'll see the levels of abstraction which are present in the C programming language. Definition of abstraction is the act or process of separating in thought of considering a thing independently of its associations or a substance independently of its attributes or an attribute or quality independently of the substance to which it belongs. Okay, I repeat the definition of the abstraction. The act or process, or I'll just remove the R's and I'll write, read the process of separating in thought of considering a thing independently of its associations or a substance independently of its attributes or an attribute or quality independently of the substance to which it belongs. We are going to separating the thought. That means we are having different modules. We are going to differ those from main parts and we are making them groups. Later on, we are going to merge all these separated tasks. Okay, example, you can see add all the scores, then divide and sum by the number of students to get the average. So we need to get the average of all the students. So for that, each and every student have 6 subject marks, isn't it? 6 subjects can be added at one place of one student. Another second student, 6 subjects will be added at one place. These are nowhere related. Student 1 marks and student 2 marks. Then student 3 marks also added separately. Student 4 marks are also added separately. Then the overall class average we need to calculate. That means we need to take the total scores of the each and every student. Then we need to sum of the totals of the student marks. Then we get the average by dividing the total of student marks divided by total number of students. If 4 students are there, total students 4 marks will be added and then divided by 4. Then we will get the average of 4 students. Likewise, each and every student has 6 subjects. Each and every task has its particular process. And this process is nowhere related to another task. But overall, all tasks are working on a major task, that is major problem. And these students can be called as subtask or sub-process. Okay. In other words, the abstraction property let us view an algorithm as a series of high-level aggregate steps with the detail hidden in a lower level. Okay, I repeat, the abstraction property let us view an algorithm as a series of high-level aggregate steps with the detail in a lower level. And instead of approaching a problem solving and worrying about each and everything, we must do to solve the problem. We can begin to look at the major steps. That means the top-down design. Okay, instead of approaching a problem and worrying about each and everything, we must do solve the problem. You can begin to look at the major steps. That means that is a top-down design. And after major steps, you can begin to fill in the how you would accomplish the major steps. So the major steps, you can begin to fill in how you would accomplish the major step. And that fill in may lead to need for additional levels to fill in those details. That fill in may lead to the need for additional levels to fill in those details. Okay, and this procedure is known as top-down design. That means we are going to have major tasks. First we are going to identify the major tasks, major steps. Then we are going to identify the sub steps under the major steps. Okay. For example, we are going to give a real-time example. That means we have to drive the car to school. Okay. So diagrammatically, I'm going to show you here. We are going to drive from here to school or home to school. So in the level one of abstraction, we are going to give a single statement, that is drive the car to school, whatever the situation it comes, whether it is a right turn, left turn, or a U-turn, or any traffic signals. Okay, so nothing to worry about that. The level one will give drive the car to school. How you drive is nowhere related. And the coming to second level, we need to get the directions from where to where. In particular direction only you have to come here. Okay, and those directions are start the car, follow the directions as it is in GPS or okay, like how GPS is going to show. We have to follow the directions and get the parking pass. Okay, and drive to the destination, find a place to park, and then stop the car. So these are the steps which are allocated in the level 2 of abstraction. You can identify level 1 and level 2. In level 1, we are going to give only one instruction, that drive the car to the school. The school address is given. From a particular place, you have to go to that particular school. You have to find out the way. In the second level, we are going to give the directions. And we are going to give the get directions, and then start the car. Then follow the directions which is given by into GPS or anything, and get the parking pass. After coming to that one, drive into the destination, then find a place to park. We have to park the car into one particular place and stop the car. Then our destination is reached. These many instructions, 1, 2, 3, 4, 5, 6, 7, these many instructions are not given in level 1 abstraction. That is, only one instruction is given, drive to school. Whatever you want to, wherever you want to, park the car. In which direction you want to come to school, you can come. But you have to drive the car to school only. In the level 1. In the second level, the directions given, you have to take the parking pass, then drive to the destination and place the car in a particular correct exact place on the parking place, then stop the car. And in the level 3, again after giving the follow directions, turn left out of your driveway and then turn right of your driveway, or at the next light, the turn right. Okay, and at the intersection with I-66, take the on ramp for I-66 west. That means any address which is given related to that particular one. This is in that instructions to the level 2. In addition to these instructions, these 3 extra instructions will be given in the third level of abstraction. This is how we are going to get the levels of abstraction. Okay, and algorithm attributes. A good algorithm should be correct, and a good algorithm should be complete. Okay, after like stakeholders, again to be correct, an algorithm must produce a result that are correct and complete given any and all sets of appropriate data. And to be correct, an algorithm must proceed through to a conclusion. So, algorithm must be given a conclusion. And coming to problem solving, in the problem solving, we are going to have a pseudocode. Okay, after algorithm, we're going to write a pseudocode. First, to produce a general algorithm, that is, we can write a pseudocode, refine the algorithm successively to get step by step detailed algorithm that is very close to a computer language. Very close to a computer language. Okay, and we are going to see the definition of a pseudocode. The pseudocode is an artificial and informal language that helps programmers to develop algorithms. Okay, the pseudocode is very similar to everyday English. The pseudocode is an artificial and informal language that helps programmer develop algorithm, and pseudocode is very similar to the everyday English. Suppose we are going to see an example like write an algorithm to determine the student's final grade and indicate whether it is passing or failing. So we need to get the final grade and mentioning that whether he is passed or failed. The final grade is calculated as the average of 4 marks. Okay. Now we are going to see the pseudocode for this one. You can see here, we are going to take the set of 4 marks, 4 subjects marks, calculate their average by summing and dividing by 4. Okay, we need to take the 4 set of marks. We need to summation of those 4 marks and then divide by the 4. Why? Because it is set of 4 subjects. And if the average is below 50%, let us assume that at particular this algorithm below 50% is failed and above 50% is passed. Just we are going to take an example. If the algorithm is the average is given below, okay, the pass marks are 50. Okay, if we got the 50, he is pass. Above the 50, pass. Below the 50, fail. If the average calculated by the above step is below 50, then print is it is fail. Okay, print it is fail. Else means if it is not below 50, that means above the 50 marks, then print pass. If he gets a above 50 marks, then print pass. So this is a simple pseudocode algorithm for calculating whether or giving the grade, final grade of a student, whether he is a fail or pass. Detailed algorithm. We are going to take the 4 subject marks M1, M2, M3, and M4. That is, we are going to write input M1, M2, M3, and 4. That means like client user has to give the input marks 1, 2, 3, 4, M1, M2, M3, and M4. In the next step, we are going to sum M1 and M2, M3, and M4. Then we are going to divide the summation result with by 4. Divide the summation result by 4. And which is assigned to grade. Which is assigned to grade, which is a variable which stores the average of these 4 subjects. And in the third steps, we are going to check whether the grade is less than 50 or not. So condition is if grade is less than 50, then print fail. Else means if the grade less than 50 is going to wrong. Okay, that means the grade is above 50, then else part will be executed, that is it will print pass. We are going to end the if here. Okay, this is a detailed algorithm, as we can also known as a pseudo. Coming to flowchart, this is about the algorithm. And after completion of algorithm, we are going to draw a flowchart, that is a pictorial representation of an algorithm. So as per dictionary, a flowchart is a schematic representation of a sequence of operations as in a manufacturing process or computer program. Either it may be manufacturing process or computer program. Okay. As a technical definition of C programming language, the flowchart is a graphical representation of the sequence of operations in an information system or program. Okay. Once again, I repeat, a graphical representation of the sequence of operations in an information system or program. In detail, the information system flowcharts show how the data flows from source documents through the computer to final distribution to your users. Okay, so the information system flowcharts show how the data flows from the source documents to the computer to final distribution to users. And the program flowcharts show the sequence of instructions in a single program or a subroutine. Okay. The program flowcharts show the sequence of instructions in a single program. The different symbols are used to draw each type of flowchart. In the flowchart, the different diagrams or different symbols are present in the flowcharts to represent each and every activity. The flowchart is a which shows a logic form of an algorithm, logical form of an algorithm, and which is easier than algorithm to understand. That means algorithm have to understand the statements, but here it shows a diagrammatical view of an algorithm. That means we can easily understand the algorithm by watching that particular images, diagrammatic representation. And the flowchart emphasizes individual steps and their interconnections. Okay, the flowchart emphasizes individual steps and their interconnections. For example, the control flow from one action to the next. So these are the different basic symbols which are present in the flowchart. We have to use one is a oval, parallelogram, rectangle, diamond, and hybrid flow line, that is arrow mark, which is going to represent the flow line. Okay. Oval will be represented to, oval is used to represent, which denotes the beginning and ending of the program. Parallelogram indicates input operations. Okay. Parallelograms are used to denote the input operations. And coming to rectangle, diagonal denotes the process to be carried out. Whatever the process, the process will be represented in the rectangle. That is addition, subtraction, or division, or it may be any other process. Diamond. Diamond denotes a decision to be made. Wherever the alternative solutions are there, we are going to give the conditions whether it is true or false. If the true, then what are the things has to be done? If the false, then what are the things to be done? And this decisions can be taken by a diamond symbol. And those statements can be written in diamond part. Okay. The program should continue along one of the two or more routes. Okay. Hybrid, it denotes the output operations. Generally, we don't use in the syllabus. Flow line, control lines, which denotes arrow marks direction of logic flow in the program. Now, this is an example of a student grade. Just now we have seen an algorithm. We are taking a 4 marks of a student, 4 subject marks, and we are going to take the input values, and then we are doing summation of those 4 marks and get the average. And finally, we are going to check whether the grade is either it may be passed or failed. The final result of a student. Okay. Now here see a oval will be represented with the start and a stop. Okay. The starting and the ending. After start, the arrow mark is going to show that from here to here we have to move. Of course, the computer compiler is going from here to here. and this will indicate the input values has to be taken at the compiler compile time. We are going to take the values input n1, n2, n3, n4 marks. Then after taking the values, we are going to here by using this arrow mark. And this is a process that we are going to add the four subjects and then divide by the four, and this average is going to be assigned to grade variable. Okay. We are going to do three process, that is addition, division, and assignment. And then after assigning this one, we are going to check whether the grade is less than 50 or not. That means whether he is passed or failed. We need to find out by using this statement. Whether if it is true, then yes, it has to print fail. Okay, it has to print the fail. Then if it is no, that means it is the grade is greater than 50. That means he is passed. So after this result, either this will print or this will print. Both will not print in any problem. Okay, this is alternative solution. That's why wherever there are alternative solutions are there, we are going to use the rhombus and then start the algorithm programming concept. Okay, this is how the program algorithm is converted into flowchart. Same these steps are written here, nothing new written in the flowchart. But the thing is, in which step has to be written in which symbol, that has to be identified with student. Inputs written in parallelogram, process is written in rectangle, the condition is written in rhombus, output statements are written in this statement. Again, stop will be given with oval. Example 2, we are going to see another problem. Write an algorithm and draw a flowchart to convert the length in feet to centimeter. In pseudocode, we are going to take the input length in feet. Okay. And in the second step, we are going to write that calculate the length in centimeters by using LCM by length in centimeter by multiplying length in feet with 30. So calculate the length in centimeter by multiplying the length in feet with 30. Okay. The print, and finally after calculating, print the length in centimeters. Okay. So this is a pseudocode input LFT, and LCM is equal to LFT multiplied with 30, then print LCM. So for that, the flowchart is, we are going to start the flowchart by using oval and writing the arrow mark to get the input LFT length in feet. Okay, this is input. And after taking the input, we are going to convert the length in length in feet to centimeter. So further, the formula is length in feet is multiplied with 30 to get the centimeters. And this is a process which is written in rectangular box. After completion, calculating the LCM, we are going to print the LCM value. That is print LCM. Then output is given here, and then start the procedure, executing procedure. So this is another example. You can see thoroughly. Okay, and then we are going to see another one. We're going to see another one. The third example is write an algorithm to draw the flowchart that will read two sides of the rectangle and calculate its area and length, width, and area. We're going to see here the pseudocode. That is, we are taking width and length, and the area is equal to length is multiplied with width and printing the area. Here also same thing, nothing new here. Okay, and Coming to flowcharts, the graph is used to depict the show a step-by-step solution using symbols which represent a task, which is going to represent a task. The symbols used consist of geometrical shapes that are connected by flow lines, that is arrow lines. Okay. And it is an alternative to pseudocoding, whereas a pseudocode is a description in verbal, flowchart is graphical in nature. Okay. These are the terminal symbols. Okay. Process symbol is a rectangle, input output symbol is a parallelogram. Data and IO input output symbol will be represented by this one cylinder. Okay. This indicates a disk storage. And these symbols can be used for printer output symbols. That means it shows the hard copy or a printer output. Okay. Rhombus is a selection that is among the alternative ways. The half page connector with this trapezium, okay, logical path, and the on page connector. This is if one page is full with a flow chart. Then if you want to draw another half of the flow chart in the next page, then we use end of this one with some numbering or alphabetical numbering. Then at the same time, the new page, we are going to start with that number in the circuit. So these are the flow lines, that is arrows from up to down and left and right. Like this, the structure is going to be given arrow marks statement 1, 2, 3. The sequence must be top to bottom. This is called as top to bottom design algorithm. Okay, this is a condition, whether it is yes, whether it is no. Okay, this is a loop conditions we are going to use. If the condition is yes, the loop statements will be repeatedly executed until these conditions get false. Okay. And this is one more example to get the calculate the birth date. Okay. So thank you for